The first thing, and probably the most important thing to remember, is that lowercase r is equal to 1 plus I, where I is the interest rate as a decimal per compounding period. We'll unpack that more shortly. The capital R part in the second recurrence relation formula, which is linked to reducing balance loans, that capital R represents the repayment amount, and the lowercase d in the third recurrence relation formula represents the deposit amount. So the most important thing to remember is that I is the interest rate as a decimal per compounding period. Let's go through an example to make this more clear. So we've got a person invests $1,000 at an interest rate of 2.4% compounding monthly, and we need to write a recurrence relation to represent this situation. So in this case, the interest rate is 2.4%. So I've written 0.024 as a decimal, and I've divided that by the compounding periods, which is 12, because we've got monthly compounding periods, and there's 12 months in a year. So if that had have said compounding weekly, I would have divided by 52. If it had have said compounding quarterly, I would have divided by 4. So when we plug that into a calculator, we get 1.002. So therefore, our recurrence relation in this situation is a n plus 1 is equal to 1.002 times by an. So we can clearly see that that looks like the first recurrence relation, which is related to compound interest. So that would be a compound interest problem. And AO is equal to 1,000. It's always important to put AO after your recurrence relation. In this case, N represents months. That means that A1 represents the balance after 1 month. Another example, we've got a person takes out a loan of $10,000 with an interest rate of 10.4%, compounding fortnightly. So as soon as I read the word loan, automatically I know that I'm going to be using my reducing balance loan formula, which is the second recurrence relation on the screen here. It says repayments are $200 per fortnight, and we have to write a recurrence relation. So first thing we're going to do is R, which is 1 plus 0.104 divided by 26. It's divided by 26 because there's 26 fortnights in a year. And when we plug that into a calculator, we get 1.004. So therefore, our recurrence relation is this. The 200 on the end there, that's relatively straightforward. There's nothing tricky about that. That's just the repayment amount per compounding period. So our recurrence relation is that, where AO is 10,000. Now, N represents fortnights in this case. So that means that if we were to find A26, then what that would represent is that would represent the amount that is left in this balance or in this loan after 1 year. So next example, we've got a person has $500 in their bank and deposits $20 per week. So since they're depositing $20 per week, that tells me that we're going to be using the third recurrence relation. If their interest rate is 7.8% compounding weekly, write a recurrence relation to model this situation. So first thing we always do is R, which I've gone ahead and done. The D value in this situation is going to be 20 because that's the amount that we're depositing. And therefore we can write a recurrence relation from that information. In the next video of this playlist, I'm going to show you guys the calculator trick, which is very, very valuable when it comes to all of this recurrence relation stuff. So I highly recommend watching the next video in this playlist.